BIC Level 2 Diploma in Plumbing Foundation 1. Section 4J/602/2496. Understand how to apply scientific principles within MES. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 2. J/602/2496. Understand how to apply scientific principles within MES. This knowledge unit provides learning in the essential scientific principles that underpin the installation, commissioning and maintenance requirements of systems and components in the mechanical engineering services industries. The unit also provides learning in a range of basic calculation methodologies underpinning system and component design. Upon completion of the unit, the learner will: Lo 1. Know the standard units of measurement used in the mechanical services industry. Lo 2. Know the properties of materials used in the mechanical services industry. Lo 3. Know the relationship between energy, heat and power in the mechanical services industry. Lo 4. Know the principles of force and pressure and their application in the mechanical services industry. Lo 5. Know simple mechanical principles and their application in the mechanical services industry. Lo 6. Know the principles of electricity as they relate to the mechanical services industry. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 3. Learning Outcome 1. Know the standard units of measurement used in the mechanical services industry. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 4. There are two assessment criteria within this learning outcome. AC 1.1. State the application and use of internationally recognized SI units of measurement. AC 1.2. State the application and use of SI-derived units. AC 1.1. State the application and use of internationally recognized SI units of measurement. The International System of Units, or SI, is based on 7 base units from which all other measurement units are derived, but not all of them are relevant to us. Of the 7 base units, there are 5 key units that we must have knowledge of. These are SI base units common to the building services industry. Base quantity. SI base unit. Name symbol. Length meter m. The unit of measurement of length in the UK. The meter is either divided or multiplied by 1000 for greater or smaller. Units I.E multiplied by 1000 to become kilometers, kilometer, or divided by 1000 to become millimeters, millimeter. We do not use centimeters, centimeter, in the construction industry. Mass kilogram, kilogram. Mass is measured in kilograms. This is not weight, as weight is measured in newtons. The mass of an object refers to the amount of matter an object contains, times second s. The second is the base unit of time. Derivatives of time are measured in multiples of 60, i.e. 60 seconds in a minute and 60 minutes in an hour. Electric current ampere. Referred to as the amp, this is the unit of electrical current. Equal to 1 coulomb per second. Temperature Kelvin K. The Kelvin is a unit of measure for temperature based upon an absolute scale. Absolute 0 K is equal to -273 OC. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 5. In addition to these, we should also know the following. AC 1.2, state the application and use of psi-derived units. Derived units are units that may be stated in terms of base units by means of mathematical symbols of multiplication and division. Some derived units have been given special names and symbols that may be used in combination with psi units and other derived units to show the units of other quantities. Look at the table below. Examples of psi-derived units expressed in terms of base units. Derived quantity. Psi-derived unit. Description. Name symbol. Area square meter m2. The m2 is derived from multiplying length and width. It is two-dimensional. Volume cubic meter m3. The m3 is derived from multiplying length, width, and height. It is three-dimensional. Speed, velocity meter per second m/s. The m/s is the distance traveled over time in a straight line and at a constant speed. Acceleration. Meter per second. Squared. m/s2. The m/s2 is the distance traveled over time that includes speeding up, slowing down and changing direction. Other metric units common to the building services industry. Quantity. Psi base unit. Description. Name symbol. Pressure bar B. The bar is a metric unit of pressure, but not part of the International System of Units, Psi. It is the unit that we measure water pressure with and is exactly equal to 100,000 pa, or 100 kpa. 1 bar is equal to 10 m of water pressure, known as head, or 100 kilopascals, kpa. Pressure pascals pa. The pascal is the psi unit of pressure. It is defined as 1 Newton per m2. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 6. Density. Kilograms per meter cubed. Kilogram/m3. The kilogram per meter cubed, kilogram/m3, is the standard unit of material density in the International System of Units, Psi. Material density is expressed directly in base psi units, and cannot be further reduced. Capacity liter L. Capacity is measured in liters, L. A liter is a measurement of 1000 centimeters cubed, centimeter 3. Area square meter m2. The m2 is derived from multiplying length and width. It is two-dimensional. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. Buy now via bic.org.uk/shop. Ebooks from just £6.99. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 8. Learning Outcome 2. Know the properties of materials used in the mechanical services industry. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 9. There are 8 assessment criteria within this learning outcome. AC 2.1. Calculate the relative densities of common materials. AC 2.2. State the principal applications of solid materials used in the mechanical services industry. AC 2.3. Identify the detailed properties of solid materials. AC 2.4. State the reasons why solid materials break down. AC 2.5. State the principal applications and basic properties of liquids used in the mechanical services industry. AC 2.6. Identify the detailed properties of water. AC 2.7. State the principal applications of gases used in the mechanical services industry. AC 2.8. Identify the detailed properties of gases. AC 2.1. Calculate the relative densities of common materials. The relative density of material is the ratio of the density of a substance to the density of a given reference material measured in G/cm3. In other words, the relative density is 1000 th of the material's density, which is measured in kg/m3. In the case of solids and liquids, the reference material is water. In the case of a gas, the reference material is air. If we know the density of a material, then calculating its relative density is a straightforward process. The density of copper is 8,920 kg/m3. If we divide this figure by 1000, we get 8,920 divided by 1000 equals 8.92 G/cm3. So, it can be said that copper has a relative density of 8.92. When we consider that water has a relative density of 1, we can say confidently that Am3 of copper has a mass 8.9 times greater than the mass of Am3 of water. Relative density, specific gravity, to air. The relative density of a gas is better known as specific gravity Y. The specific gravity of a gas is measured against a known gas. This gas is air and it is measured as 1. This means that any gas that is lighter than air, such as natural gas, helium and hydrogen, their specific gravities will be less than 1, and any gas that is heavier than air, such as propane and butane, will have specific gravities greater than 1. The table below shows the specific gravities of some common gases. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 10. The specific gravities of common gases. Gas. Specific gravity. Sg. Air 1.000. Helium, He 0.138. Hydrogen 0.0696. Methane, CH4 0.5537. Natural gas, typical, 0.60, 0.80. Oxygen, O2 1.1044. Ozone 1.660. Propane, C3H8 1.5219. Water vapor 0.6218. Relative density to water. The relative density of solid or a liquid is measured against the density of water. Water is taken to have a relative density of 1. This is because water has a mass of 1000 kg/m3 at 40 C. Any material with a relative density of less than 1 is lighter than the same quantity of water, and any material that has a relative density greater than 1 is heavier than water. Below is a table of some of the common materials used in the plumbing industry. The relative densities of common materials. Product relative density. ABS, extrusion grade 1.05. Brass, cast rolled 8.4, 8.7. Copper 8.89. Ice, 0 OC, 32 OF, 0.92. Lead 11.34. Iron cast maximum 7.13. Plastics, foamed 0.2. Plastics, solid 1.2. Polyethylene, MD 0.97. Polypropylene 0.91. Porcelain 2.5. PVC 1.39. Steel, carbon 7.8. Tin 7.31. Water 1.0. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 11. AC2.2 state the principal applications of solid materials used in the mechanical services industry. Metals. Metals are one of the principal materials that are used in the plumbing industry. From pipework to boilers. The main material chosen because of its ability to withstand the wear and tear of everyday usage is metal. However, there are many different types of metals and not all are suitable for use in plumbing systems. Metals can be divided into 4 very different groups. 1. Pure metals. 2. Alloys. 3. Metals that are ferrous. 4. Metals that are non-ferrous. Pure metals. Pure metals are those that consist of only one atom and contain little or no impurities. They are smelted directly from the ore after it is mined into ingots and sold. These are then smelted into plates and tubes by the manufacturer as required. Below is a table of the pure metals we may find in plumbing. Metals and their properties. Metal type description or type. Iron. Ferrous iron is extracted from rock sand. Minerals that are rich in iron oxides. They vary in color from dark gray, bright yellow, deep purple to rust red. Copper. Non-ferrous copper can be economically extracted from many different ores. It is usually purified using the electrolysis process. Copper belongs to the gold, silver, and copper group of metals. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, PIC Limited. Editor, PIC Limited. Design, PIC Limited. PIC Level 2 Diploma in Plumbing Foundation 12. Aluminium. Non-ferrous aluminium is the most abundant metal on Earth. Even so, it is very expensive to produce because of the amount of electricity used in the extraction process. Aluminium ore is better known as bauxite. Lead. Non-ferrous lead is normally found in the galena ore. Lead and silver are often found together in the same vein and both can usually be extracted. Lead is bluish-white when freshly cut but quickly tarnishes to a dull gray when exposed to air. Zinc. Non-ferrous zinc usually occurs in thin veins, known as rakes, or as a secondary deposit associated with other minerals. Zinc is primarily used as an anti-corrosion coating on galvanized pipe, or blended with copper to make brass. Tin. Non-ferrous tin is one of the easiest ores to mine, and has been mined in the UK for 2,000 years. When tin is blended with copper, they form a highly corrosion-resistant but expensive alloy known as bronze alloys. An alloy is a blend of two or more elements, one of which must be a metal. Alloys often have properties that are very different from the individual parent metals from which they are blended. Alloys are typically harder than the parent metals, which often makes them more useful than the metals they contain. The content of this document is copyright symbol PIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, PIC Limited. Editor, PIC Limited. Design, PIC Limited. PIC Level 2 Diploma in Plumbing Foundation 13. Typical alloys in the plumbing industry are listed below. Brass, a mixture of copper and zinc. Used extensively for fittings and components. It corrodes when in the presence of hard water, as copper and zinc are dissimilar metals at opposite ends of the electro-chemical series of metals. Electrolytic corrosion occurs where the noble metal copper destroys the weaker sacrificial metal zinc. For this reason, low zinc content brass is made, which is dezincification resistant. Bronze, a mixture of copper and tin. Bronze was used in the past for back boilers behind coal fires. Now it is mainly used for the bodies of hot water secondary return pumps. Gunmetal, a mixture of copper, tin and zinc. A corrosion-resistant metal similar to both brass and bronze, that is used for fittings and components where corrosion protection is required. Steel, a mixture of iron and carbon. Stainless steel. There are many different grades of stainless steel and some are better at resisting corrosion than others. It is a mixture of iron, carbon and chromium with a minimum chromium content of 10.5%. The more chromium is added, the better the steel's resistance to corrosion. Lead-free solders, a mixture tin and antimony or tin and silver. Ferrous metals. Ferrous metals contain iron, such as steel and cast iron. Ferrous metals corrode easily in the presence of water and air, forming a coating of ferrous oxide, which is better known as rust. Non-ferrous metals. Non-ferrous metals are those that do not contain iron. They do not rust. However, they can corrode over time, forming oxides on the metal's surface. Non-ferrous metals include copper, zinc, brass, bronze, tin and aluminium. Plastics. Plastics play a huge part in the installation of modern plumbing systems. Most systems can now be installed in some sort of plastic material, be it cold water, hot water, central heating or sanitation systems, but not all. Plastics are suitable for all jobs. Because of this, it is important that plumbers know their plastics so that mistakes at installation stage do not occur. There are two types of plastics category. These are 1. Thermoplastics, and 2. Thermosetting plastics. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 14. Thermoplastics. Thermoplastics are made from polymer resins that become liquid when heated and hard once they are cooled. However, they also become brittle in freezing temperatures and are liable to fracture. These specific characteristics are reversible with thermoplastics, and they have the ability to be reheated, remolded, cooled and frozen repeatedly with no loss of performance. This makes them recyclable. There are many thermoplastic types used in the plumbing industry. Type of plastic uses: UPVC, CUPVC, unplasticized polyvinyl chloride, used extensively for cold water mains, cold water installations, chlorinated unplasticized polyvinyl chloride, solvent welded and push-fit soil and vent pipes, solvent welded waste and overflow pipes, underground drainage pipes, gutters and rainwater pipes, polyethylene, MDPE, HDPE, MDPE, medium density polyethylene, used for underground cold water mains, colored blue, cold water storage cisterns, underground gas pipes. HDPE, high-density polyethylene, used for underground cold water mains, colored black. Polypropylene, used for push-fit waste and overflow pipe, cold water storage cisterns. Polybutylene, used for push-fit hot and cold water installations, central heating installations. ABS, acrylonitrile butadiene styrene, used for water supply, potable water for apartments, offices, commercial installations. Solvent welded waste and overflow pipes. Thermosetting plastics. Thermosetting plastics differ from thermoplastics in that they can only be heated and molded once. They cannot be reheated and remolded, and their initial shape is permanent. They do not melt when heated. Thermosetting plastics include polyester, epoxy resin, melamine and electrical switches and sockets. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 15. Ceramics and fireclays. Ceramics and fireclays are used extensively in the plumbing industry for sanitary appliances, heavy-duty sinks, underground pipes and wall tiles. There are three basic types. A. Vitreous china. This is a clay material, which is sprayed with an enameled surface. It is used to manufacture bathroom appliances such as W.C.S and cisterns, wash hand basins and bidets. It is made from very watery clay, known as slip, which is poured into the mold, allowed to set and then fired in a kiln at high temperature. B. Fire clay. This is used for heavy-duty appliances, such as Belfast sinks, London sinks, cleaners and butlers' sinks and shower trays where there is greater risk of damage and a higher temperature water may be required. C. Ceramic tiles. These have many applications and are used extensively in bathrooms, kitchens, floors, and swimming pools. Each of the materials that we have just identified have specific applications within the plumbing industry. Look at the table below. The applications of materials. Material type application. Metals. Copper tubes and fittings, heat exchangers. Brass compression fittings, boiler components. Bronze heat exchangers where the risk of corrosion is high. Secondary circulation pumps for hot water systems. Gunmetal compression fittings and boiler components where the need for corrosion resistance is required. Zinc used in its molten state as galvanizing for galvanized low-carbon steel tubes and fittings. Iron in its cast form. It is used for cast iron pipes, gutters, and boiler heat exchangers. Steel. Low-carbon steel used primarily for tubes and fittings. Stainless steel. Vandal-proof sanitary ware, kitchen sinks, tubes and fittings where there is a need for ultra-hygienic conditions. Plate heat exchangers in boilers. Hot water cylinders. Lead sheet roof weatherings. Tin mostly found in lead-free solders. Plastics. UPVC. CUPVC. Unplasticized polyvinyl chloride. Water mains. Solvent welded and push-fit soil and vent pipes. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 16. Solvent welded waste and overflow pipes. Underground drainage pipes, gutters and rainwater pipes. Chlorinated unplasticized polyvinyl chloride. Cold water installations. Polyethylene. MDPE. HDPE. MDPE, medium density polyethylene. Underground cold water mains, colored blue. Cold water storage cisterns, underground gas pipes. HDPE, high density polyethylene, underground. Cold water mains, colored black. Polypropylene push-fit waste and overflow pipe, cold water storage cisterns. Polybutylene push-fit hot and cold water installations, central heating installations. ABS acrylonitrile butadiene styrene. Water supply. Potable water for apartments, offices, commercial installations, solvent welded waste and overflow pipes. Fiberglass baths and shower trays. Ceramics. Vitreous china sanitary appliances, such as WCs, wash basins, bidets. Fire clay heavy-duty sinks, Belfast sinks, London sinks. Cleaners' sinks and butlers' sinks. Shower trays. Underground drainage pipes, spigot and socket type, with mortar joints. AC2.3 Identify the detailed properties of solid materials. There are a variety of materials used in the plumbing industry including plastics, metals and ceramics. Each one has a unique set of properties that make it suitable for the job it has to do. Below is a list of properties common to most materials. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 17. The properties of materials. Property description. Hardness, the resistance of material to being cut, deformed or bent. Toughness, the amount of energy a material can absorb without breaking or fracturing. Tensile strength. The maximum force a material can withstand when being pulled apart. Some materials such as plastics and some metals will stretch when subjected to tensile strength, while other materials like cast iron and concrete will simply snap with no deformation of shape. Compressive strength. The maximum force a material can withstand when being crushed, see above. Shear strength, the maximum force a material can withstand when being ripped, see above. Torsion strength, the maximum force a material can withstand when being twisted, see above. Malleability. The amount of hammering and shaping a material can withstand without breaking, splitting or cracking. Malleability is particularly desirable in metals such as sheet lead. Ductility. The amount that a material can be pulled, pushed, stretched or deformed without breaking. It is often characterized by a material's ability to be stretched into a wire. Copper is a very ductile metal because it can be easily bent and formed into different shapes. Elasticity. The length that a material can be stretched and return to its original length when released. Heat and electrical conductivity. The measure of how well a material conducts heat or electricity. Heaviness, the denseness of a material. A dense material will be heavy in relation to its size. Strength, the measure of how materials withstand heavy loads without breaking. AC 2.4 state the reasons why solid materials break down. Atmospheric corrosion. Atmospheric corrosion is not caused by one single element in the atmosphere. It is a combination of many atmospheric substances that create different erosion and corrosion situations. Corrosion alters the micro structure of the material, drastically reducing the material's strength and useful life. In most cases, this chemical reaction is permanent and cannot be reversed. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 18. The key factor in corrosion is moisture. This occurs because of precipitation, rain, fog, dew and humidity. This, when mixed with substances like carbon dioxide and sulfur trioxide, which are both present in our atmosphere, creates corrosion agents such as carbonic acid and sulfuric acid that can eat through common metals such as copper, brass and aluminium. Water, when mixed with some gases present in our atmosphere, creates very weak solutions of acids, which does much damage to metals. Take a look at the following. Carbon dioxide equals CO2. Sulfur trioxide equals SO3. Water, in the form of vapor or rain, equals H2O. H2O plus CO2 equals H2CO3, better known as carbonic acid. H2O plus SO3 equals H2SO4, better known as sulfuric acid. Salts and chlorine further aggravate the situation by creating electrolytes, especially in industrial areas, which Cause electrolytic and galvanic corrosion. This will be discussed in detail a little later. Temperature too can affect corrosion of this type, as higher temperatures lead to a highly reactive electrolyte. The continued study of atmospheric corrosion is vital, since this type of corrosion is widespread among the various types of corrosion damage. The deterioration can be frequent, affecting both indoor and outdoor plumbing installations, appliances and utilities. Studying corrosion helps to identify specific root causes of chemical and electrolytic reactions in many different metal and plastic types with atmospheric substances, such as oxygen, sulfur dioxide and trioxide, and salt crystals. Oxidization of metals. The Earth's natural environment contains 20% oxygen and water vapor, which is sufficient to cause the gradual corrosion of those metals containing iron, such as steel. The water and oxygen react with the iron to form a substance known as ferrous oxide, which is better known to us as rust, but not only steel and iron create oxides. Most metals create some form of coating, some are harmful and some protective, when exposed to water and oxygen in Earth's atmosphere. The images on this page show two types of oxides: ferrous oxide, rust, and copper oxide. Ferrous oxide is destructive to the metal, but copper oxide creates a protective coating called a patina, which helps to protect the copper from further corrosion. Ferrous oxide, rust. The metal has undergone a chemical change, blistering and altering the molecular structure of the steel. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 19. The effect of rust, ferrous oxide, on an old galvanized steel cold water storage cistern. Eventually the rust will penetrate all the way through the metal and the cistern will leak. Other forms of metal corrosion. There are other forms of corrosion that occur when using differing metals in the same installation, such as steel and copper, and others that occur because of high turbulent flow rate within hot and cold water systems. Some types of corrosion occur because of the type of water in a specific area. Whatever the cause, we as plumbers must learn to recognize, diagnose and, if possible, eliminate the corrosion when it occurs. Here, we will investigate A. The electromotive series of metals. B. Electrolytic corrosion. C. Galvanic corrosion. D. Erosion corrosion. E. Pitting corrosion. The electromotive series of metals. The table, left, shows the electromotive series of metals. Also known as the electrochemical series of metals, it indicates those metals that are electrochemically opposed to each other. The further the metals are apart on the table, the more opposed they are. Electrolytic corrosion. Electrolytic corrosion is often confused with galvanic corrosion, but there is a subtle but significant difference. Electrolytic corrosion between two dissimilar metals is copper oxide forming on a copper roof. The green color is called the patina, and this helps to protect the copper underneath. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 20. dependent upon an external source of electromotive force, EMF. In other words, for electrolytic action to begin, there has to be a leakage of electrical current from an external source. Galvanic corrosion. Galvanic corrosion, also called galvanic action, dissimilar metal corrosion and often wrongly termed electrolytic corrosion, occurs when two dissimilar metals are in contact with each other through the presence of an electrolyte. When two dissimilar metals are immersed in an electrolyte, such as water, a small electrical DC current is generated that flows from the less noble anodic metal to the noble cathodic metal. During this process, the anodic metal is destroyed. As a by-product, hydrogen gas is produced as the electrical current breaks down the water, H2O, releasing the hydrogen. An electrolyte is a fluid that allows electricity to flow through it. Erosion corrosion. Erosion corrosion occurs in pipes and fittings as a result of fast-flowing, turbulent fluids and gases. As the tube or fitting erodes, the symptoms become worse, eventually leading to failure and leakage. Erosion corrosion can be a result of poor workmanship, such as using too many elbows, or by not removing the burrs from tubes when they have been cut. Burrs will disrupt the smooth flow of water, causing localized turbulence and unwanted noise within the pipework. Pitting corrosion. Pitting corrosion is a localized form of corrosion that is usually confined to a small area of the pipework and components, and takes the form of small cavities and pits in the metal. Pitting usually affects central heating systems and steel radiators in particular. It can be as a result of galvanic action mentioned earlier or electrolytic corrosion. Methods of preventing corrosion. The effects of erosion corrosion are clearly visible on this section of Cooper tube. Pitting corrosion in copper pipe. Galvanic corrosion between a copper pipe and a galvanized steel pipe. The less noble galvanized steel has been eaten away by the copper. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 21. Design, material choice, installation and operating conditions all play a major role in the overall performance of the materials used in hot, cold and central heating systems. The detailed layout of the system is always the responsibility of the design engineer. Nevertheless, the following points have been proven time and again to be of vital importance when dealing with corrosion and its prevention. Low flow rates in partially filled pipework encourages the formation of system debris, and this encourages pitting corrosion. When this occurs in copper pipes, waterline attack is seen. When high flow rates are noted, this encourages erosion corrosion, especially at points where there are sharp, sudden changes in direction and where there are deposits of solder and flux that lie in the pipework. Pipe ends that have not been cut square or have not been deburred are vulnerable to turbulent flow. And this too encourages both pitting and erosion corrosion. Pipe runs and dead ends which supply services that are little used can be subject to microbial corrosion. The following is a list of do's and don'ts that should be considered to comply with best practice. All pipes and fittings to be stored in dry clean conditions. Pipe ends to be capped at site and at day joints. You cut pipe ends to be deburred and re-rounded using the correct tools. You solder and flux must conform to the appropriate specification and be used in accordance with the manufacturer's recommendation. You apply flux to pipe end only. Avoid excess, and if possible remove any flux prior to heating. You make sure the flux is compatible with the pipe material. You thoroughly flush out system before use. You ensure disinfection is carried out in accordance with PSN 806 and thoroughly flushed out after treatment. You use inhibitors with central heating systems. You fit hot water cylinders that contain sacrificial anodes. You avoid the use of acid and chloride-bearing flux. You do not overheat during fabrication of capillary joints. You do not over-tighten compression fittings. You pipes which have sustained internal damage should be rejected. You avoid bimetallic contacts or use of different metals in the system. You never leave a system partially filled with water for long periods immediately after installation. You avoid build-up of stagnant or semi-stagnant water in pipe runs. You avoid unnecessary use of water softeners. UV damage to plastics. Most plastics are vulnerable to deterioration by the effects of the ultraviolet, UV, part of the spectrum from direct sunlight. UV light is present, even on cloudy days. When plastics are subjected to UV light, the color. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 22. Of the plastic changes and its surface becomes brittle and chalky in texture. This often happens in a very short time frame and eventually leads to cracking and failure. Polypropylene waste pipes and medium-density polyethylene water pipes are extremely susceptible to UV degradation. Acrylonitrile-butadiene-styrene, ABS, pipework and fittings are also severely affected with prolonged exposure to the UV daylight. Heat damage to plastics. Probably the most limiting factor of plastics when used in plumbing installations is the effect of heat on the material. In high-temperature situations, the plastic has a tendency to soften and thermally degrade. In some instances, thermal degradation occurs at much lower temperatures than those that cause mechanical failure. All plastics will experience some form of thermal degradation during their working lives with chemical reactions that cause both physical and optical changes. Reduced ductility leading to embrittlement. Chalking. Color changes. Cracking. Photodegradation of plastics. Natural light and electrical fluorescent light causes a yellowing of plastic. This is known as photodegradation, and is generally very pronounced on light-colored plastics. Oxidative degradation of plastics. In basic terms, this is the degradation of plastics due to the effects of oxygen. Color changes are often the first of the effects coupled with a change in the flow capabilities of the material. Polypropylene, polyethylene, and acrylonitrile-butadiene-styrene are the most severely affected. Polyvinyl chloride, PVC, however, is unaffected by oxidative degradation. AC2.5 state the principal applications and basic properties of liquids used in the mechanical services industry. Plumbing, by its very nature, means that we design, install, commission and maintain systems that contain fluids of one sort or another. Below are some of the liquids that you may come across in your working life. 1 water, 2 refrigerant, 3 antifreeze/glycol mixes, 4 fuel oils. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 23. 5 lubricants/greases. In this assessment criteria, we will investigate these liquids and how they are used within the plumbing industry. Water. We use water every day of our lives for drinking, washing and cooking. It also has a multitude of uses in industry and is known as the universal solvent because of its ability to mix and dilute other chemicals and compounds. For example, it takes 100 tons of water to make 1 ton of steel. Refrigerant. A refrigerant is a chemical used in cooling and heating systems such as air conditioning, refrigerators, freezers, and heat pumps, that has an extremely low boiling point. It is used in 2 states, those of liquid and gas. Most refrigeration/heat pump systems rely on a chemical reaction to extract heat, or supply heat in the case of heat pumps, to buildings or spaces. They form a key part of the vapor compression refrigeration cycle. When a refrigerant gas is compressed, it changes its state to a liquid. The gas is compressed by the compressor and in the process, it generates heat. In a heat pump, the heat is released via the condenser into a heat exchanger, which is used to heat water. This can then be used in underfloor heating systems. When the pressure is released by the expansion valve, it generates cold, which is passed into a space, a room or a refrigerator, by the evaporator. At this point, the refrigerant liquid returns to a gas. There are many different refrigerant gases. Early refrigerants were toxic and this led to the development of chlorofluorocarbons or CFCs, which were colorless, odorless, non-flammable and non-toxic. However, it was discovered that CFCs, when leaked into the atmosphere, caused damage to Earth's ozone layer. Today, modern refrigerants have been developed that still retain many of the qualities of CFCs, but do not cause environmental damage and are completely safe and non-toxic. Antifreeze/glycol mixes. Glycol, when mixed with water, is used as an antifreeze in solar hot water systems. It protects solar panels from freezing during the winter when added to the sealed solar panel circuit. The antifreeze solution should be checked regularly as its antifreeze capability diminishes with time and the solution can become corrosive the longer it is in the system. Vapor compression refrigeration cycle. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 24. Glycol is available in 2 forms: ethylene glycol and propylene glycol. Propylene glycol is the preferred solution as ethylene glycol is highly toxic. Fuel oils. There are many different fuel oils. However, most domestic oil boilers and appliances use kerosene, known as C2 grade 28-second viscosity heating oil. Kerosene is a thin, clear flammable fuel formed from hydrocarbons. It is made from the distillation of petroleum spirit at temperature of between 150 oC and 275 OC. It has a relative density of 0.780.81 g/cm3, making it thinner than water. The heat released from the combustion of kerosene is 43.1 mJ/kg. Lubricants/greases. A lubricant is a substance, often a liquid or a grease, introduced between two moving surfaces to reduce the friction. This improves efficiency and reduces wear. There are many types of lubricants used in the plumbing industry. Silicone grease and spray. Used for general lubrication of plumbing parts for water and drainage systems. It is also used when jointing push-fit plastic pipe jointing systems to lubricate the rubber seals. Graphite paste, used for lubrication of gas taps. Cutting oils. Used as a lubrication when threading low-carbon steel pipe. It helps to prevent overheating of the cutting dies. Penetrating oils. Used to help loosen tight and rusted nuts. AC 2.6 Identify the detailed properties of water. Earlier in this unit, we looked at the uses of water in our daily lives, but what do we actually know about water? Water is a compound, a mixture of 3 atoms, 2 hydrogen and 1 oxygen, which together make up the most abundant compound, H2O, on Earth. Water covers 7/10 of Earth's surface and is key to life here on Earth. As we shall see, it has many properties. Boiling/freezing point. The boiling point and the freezing point of water both vary with pressure. At atmospheric pressure, 0 bar, water has a boiling point of 100 C and a freezing point of 00 C. As the pressure of the water rises, so does the boiling point. Conversely, the higher the pressure, the lower the freezing point. If the pressure is lowered below atmospheric pressure, then water will boil at less than 100 OC. For example, the boiling point of water at the summit of Mount Everest is 69 OC. The water molecule. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 25. Below is a chart showing the boiling points of water at various pressures. Change of state and molecular changes. Water can be found in all 3 states of matter: solid, ice, liquid, water, and gas, steam. Density at differing temperatures. Water has a maximum density of 1000 kg/m3 at 4 OC. If the temperature is raised above or below this, then water loses density. This peculiar behavior is known as anomalous expansion. At 0 OC, water has a density of 915 kg/m3. At 100 OC, water has a density of 958 kg/m3. These two figures can be expressed as a percentage. When water freezes, it expands by 10%. When water reaches boiling point, it expands by 4%. When water is turned to steam, it expands violently by 1600%. Centimeter 3 of water creates 1600 centimeters 3 of steam. Steam/superheated steam. Steam is the gaseous state of water and is achieved by heating water to its boiling point. To raise 1 kilogram of water through 100 C, take 419 kg/kilogram. At this stage, the water is at 100 OC but it is still water. To turn it into 100 OC of steam requires a further 2252 kJ/kg of heat. In this state, the steam is said to be saturated steam. In other words, it is saturated with water droplets, which prevents the temperature of the steam being raised any further. To increase the temperature of the steam, these water droplets must be removed by passing the steam over another heat exchanger. The dry steam can then be reheated to a higher temperature, hence the term superheated. Capillarity or capillary attraction uses two of water's qualities, those of cohesion and adhesion. Water droplets always attract those of other water droplets. In this way, two small pools of water will become one big pool because like atoms attract each other. This is known as cohesion. Adhesion is water's ability to stick to other surfaces. Water will wet other objects because the water sticks. Table 11. Boiling point of water by pressure. Pressure. Boiling point. Temp. Specific heat. Capacity. Bar head. M. K par degree C kJ/kg. 000 100.00 419.06 1.010.0 100.0 120.42 505.6 2.020.0 200.0 133.69 562.2 3.030.0 300.0 143.75 605.3 Table 12. Amount of energy required to change water to steam. Water evaporation steam. Pressure temp, HF, HFG, Hg. Bar K par degree C kJ/kg 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 00100.00 419.0 2257.0 2676.0 The content of this document is copyright symbol BPIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BPIC Limited. Editor, BPIC Limited. Design, BPIC Limited. BPIC Level 2 Diploma in Plumbing Foundation 26. To them. Capillarity or capillary attraction is the ability of a fluid, in this case water, to flow between narrow spaces against the effects of gravity. It is a system of fluid mechanics that is used every time we solder a fitting. The solder is drawn into the fitting, irrespective of the position or angle of the fitting. The drawing, left, shows the effects of capillary attraction on plates of glass placed in a tank of water. The closer the plates are drawn together, the higher the water rises. This action is a direct result of the surface tension of the water, caused by its cohesion acting with the water's adhesive force between the water and the plates of glass. The effect lifts the water between the glass plates. Water hardness comes from naturally occurring calcium and magnesium salts, which are dissolved from the rocks on which the rain falls. Earth's atmosphere is full of impurities and contaminants such as carbon dioxide, CO2, and sulfur trioxide. So 3. As the rain falls to the ground, it absorbs some of these impurities, becoming weakly acidic in the process, H2O plus CO2 equals H2CO3 or carbonic acid, H2O plus SO3 equals H2SO4 or sulfuric acid. When this weak acidic solution falls on the ground, it dissolves some of the minerals it falls on. For instance, if the rain falls on peat, CO2 is added because of the CO2 in the decaying vegetation. If the rain falls on limestone, then the water becomes temporarily hard as the acid is turned to alkali by the limestone. Soft water contains carbon dioxide, making the water soft. The water has a low pH value, below 7. Soft water, being acidic, can destroy some metals such as copper and lead. Because of its ability to dissolve lead, it is known as plumbo-solvent. Soft water lathers soap easily. Temporarily hard water becomes temporarily hard as a result of passing through calcium carbonate, CaCO3, of which limestone and chalk are two examples. In the process, the water becomes an alkali solution with a pH value of more than 7. Temporarily hard water can be made soft by boiling, but, in the process, it leaves behind the calcium carbonate that was dissolved by the acidic rain. This is known as limescale. The process is known as precipitation. Temporary hard water has detrimental effects on plumbing systems. It can lead to scaling of pipes and boilers and causes corrosion in systems installed in copper pipe work. Scaling pipe work can result in poor flow rates, bad heat transfer and fuel wastage. Soap does not lather well with capillary attraction. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 27. Temporarily hard water. Permanently hard. Permanently hard water occurs as a result of passing through calcium sulfide, CaSO4, or magnesium sulfide, MgS. In the process, the water becomes an alkali solution with a pH value of more than 7. This type of hard water cannot be softened by boiling but does not scale like other types of hard water. Soap does not lather well with permanently hard water. Acidity and alkalinity, pH value, the indicator of acidity and alkalinity of water is the pH value. Water that has a pH value of 7 is neutral. It is neither acidic nor alkali. A pH value above 7 mean that the water is alkali. A pH value below 7 means that the water is acidic. AC 2.7 state the principal applications of gases used in the mechanical services industry. All gases, with exception of steam, are liquids that have boiled and evaporated at ultra-low temperatures. In normal atmospheric temperature and pressures, these liquids exist in their gaseous state. The gases and their properties. Air. Air has only limited uses in the building services industry. It can be used as a heating medium in warm air systems. The air is warmed by a warm air heater, usually gas-fired, and then distributed throughout the property by ductwork. How water becomes hard or soft. The pH scale. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. PIC Level 2 Diploma in Plumbing Foundation 28. B. Used as a pressure charge in expansion vessels installed on sealed heating systems and unvented hot water systems. C. Used to clear blocked drains when compressed to very high pressures. Steam. The use of steam as a heating medium has declined over recent years. However, steam is now used in many modern applications. Combined heat and power, CHP. With these systems, the steam is used to generate electricity and the excess steam is used to heat a district heating system. Steam is still used for heating, especially for large industrial systems. Hot water production using large hot water calorifiers for industrial applications. Electricity generation. Liquid petroleum gas, LPG. LPG is a flammable gas that is heavier than air. Most LPG is a byproduct of oil production. In its clean state, LPG can be used in areas where access to the mains natural gas is difficult. It is used to heat homes via LPG, boilers and gas fires, and for cooking appliances. Plumbers also use LPG with their blowtorches. There are two basic types. Butane. It has a high calorific value and a high temperature flame. However, it suffers from the fact that its boiling point is rather higher at -50 C. This means that on very cold days, the liquid butane will not expand to a gas. Propane. This does not suffer the problems of butane, as its boiling point is -45 C. Its calorific value is slightly less than butane with a slightly cooler flame. However, its ability to boil at low temperatures makes this the most widely used LPG type. Natural gas. Natural gas is the most widely used fuel for home and business heating and cooking in the UK. It is primarily a mixture of 5 gases. Methane CH4, 92%. Ethane C2H6, 3%. Propane C3H8, 3%. Butane C4H10, 1%. Nitrogen N2, 1%. 4 of these gases, methane, ethane, propane and butane, are flammable. Nitrogen is inert. There are also traces of carbon dioxide, CO2, and hydrogen, H, mixed in. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 29. Natural gas is always found when drilling for oil. The gas is extracted from deep within the earth, pumped ashore and cleaned of a waxy oil deposit called naphtha. At the refinery, the distinct smell is added. This is a chemical called mercaptan and is necessary because ing has no natural smell. Ing is lighter than air, having a specific gravity of 0.6–0.8 of that of air. Carbon dioxide. Carbon dioxide, CO2, is used as freezing agent with pipe freezing kits. Refrigerant gases. Please refer to AC 2.5, Describe Principal Applications and Basic Properties of Liquids, 2, for information regarding refrigerants in liquid and gaseous states. AC 2.8 Identify the detailed properties of gases. Gases behave very differently from the other two states of matter, liquids and solids. Gases have neither a fixed shape nor a fixed volume. Their shape is determined by the container in which they are held. We measure gases by 3 variables. A. Pressure. B. Temperature. C. Volume. Pressure. The gas exerts this force on the walls of its container equally. An example of this is a balloon that is inflated. The balloon expands because the gas inside is at a higher pressure than the air that surrounds it. The balloon expands equally because the pressure inside is acting equally across the whole of the balloon's surface. If the balloon is released, the air will move from the area of high pressure, inside the balloon, to the area of low pressure, outside the balloon. Temperature. The temperature of a gas is a measure of the mean kinetic energy of the gas. The gas molecules are in constant but random motion. The higher the temperature, the greater the motion. As the temperature falls, high pressure to low pressure movement. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 30. The kinetic energy and therefore the motion decreases. Volume. The volume of the gas is affected by both pressure and temperature. The pressure is constant if the temperature is constant. If the temperature rises, then both pressure and volume increase. These three factors, pressure, temperature and volume, form the basis for two very important gas laws. Charles' Law. Boyle's Law. Charles' Law. In 1802 Jacques Charles discovered that if a known quantity of gas is held at a constant pressure and temperature, then its volume will also remain constant. If the temperature is raised, then its pressure and volume also increase. The rise in pressure is inversely proportional to the rise in temperature. The mathematical equation for this is as follows. Divided by equals divided by where V equals volume, T equals temperature. Boyle's law. Boyle's law, discovered by Robert Boyle in 1662, states that a volume of gas at a fixed temperature is inversely proportional to the pressure exerted on it. In other words, if 1 m3 of gas at 1 bar pressure is compressed into a space 0.5 m3, then its pressure will double to 2 bar. This happens because the molecules of gas have less room to move, because the volume that the gas has to occupy has halved. This can be expressed as a mathematical equation. Equals where 1p equals starting pressure, V1 equals starting volume, volume reduced equals pressure increased. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 31. 2p equals finishing pressure. V2 equals finishing volume. The table below illustrates the point. Table 13, sample of gas at constant temperature and varying pressure. Test pressure volume formula calculation. 110 kPa 200 cm 3 pxv equals k10 x 200 equals 2000. 220 kPa 100 cm 3 pxv equals k20 x 100 equals 2000. 340 kPa 50 cm 3 pxv equals k40 x 50 equals 2000. 480 kPa 25 cm 3 pxv equals k80 x 25 equals 2000. 160 kPa 12.5 cm 3 pxv equals K 160 x 12.5 equals 2000. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 32. Learning Outcome 3. Know the relationship between energy, heat and power in the mechanical services industry. Energy, heat, power. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 33. There are 6 assessment criteria within Learning Outcome 3. These are: AC.3.1. Identify the relationship between the Celsius and Kelvin temperature scales. AC.3.2. Identify the terminology associated with a change of state. AC.3.3. Identify the terms latent and sensible heat as they apply to liquids and gases. AC.3.4. Identify the methods of heat transfer. AC.3.5. State how units of energy and heat are related and derived. AC.3.6. State how to carry out simple heat, energy and power calculations. Energy, heat and power are closely linked. It is almost impossible to have one without the other two. The first law of thermodynamics states that energy can neither be created nor destroyed. Energy is transferred from one form to another. In other words, energy, heat and power are all related. Where there is one, there will always be another. Consider the following. The unit of power, the watt, is the SI unit for power. It is equivalent to 1 joule per second, 1 J/s. Or in electrical units, 1 volt ampere, 1 V times A, DC circuits. The unit of heat, the joule, is unit of heat. 4.186 joule of heat energy, equals 1 calorie, is required to raise the temperature of 1 g of water from 0 oC to 1 oC. This is usually rounded up to 4.19 J/G4. Calculation purposes. The unit of energy also the joule, see above. Specific heat capacity. The specific heat capacity of a substance is the amount of heat required to change a unit mass of that substance by 1 degree in temperature. It is measured in kilojoules per kilogram per degree Celsius, kJ/kilogram/OC. In this part of the unit, we will investigate the relationship between heat, power, energy and temperature, and its consequences for building services industry. AC 3.1 Identify the relationship between the Celsius and Kelvin temperature scales. Temperature can be defined as the degree or intensity of heat present in a substance or object, especially as expressed according to a comparative scale and shown by a thermometer or perceived by touch. In other words, temperature is a measurement of how hot or cold an object is. It is measured using a thermometer, of which there are many different types. A thermometer measures how much energy is contained within the object. Temperature is usually expressed in terms of units or degrees on a standard scale, usually Celsius, OC, or Kelvin, K. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, PIC Limited. Editor, PIC Limited. Design, PIC Limited. PIC Level 2 Diploma in Plumbing Foundation 34. Celsius, OC, this scale, using increments of 1 degree, 10, is the most widely used by the building services industry. It has a 0.0 OC, which corresponds to the temperature at which water will freeze. Kelvin, K, this has the same increments as the Celsius scale. This means that if the temperature rises or falls by 1 OC, then the temperature also rises or falls by 1 K. However, the Kelvin scale has a minimum temperature that corresponds to the point at which all molecular motion stops. 0 K is known as absolute zero, and is equal to -273 OC. Therefore, -273 OC equals 0 K, or temperature K equals temperature OC plus 273. AC 3.2 Identify the terminology associated with a change of state. Everything on Earth and in space is made of matter. Matter can exist in 3 states. 1 liquid, 2 solid, 3 gas. Each of these states can be changed by the addition or removal of heat. For example, if heat is applied to ice, solid, it becomes water, liquid, and if more heat is applied, the water will evaporate to become steam, gas. These transitions will also work in reverse when heat is taken away, steam to water to ice. Each of these phases is given a name. Ice, solid, to water, liquid, equals melting. Water, liquid, to steam, gas, equals evaporation/vaporization. Steam, gas, back to a water, liquid, equals condensation. Water, liquid, to ice, solid, equals solidification. Under certain conditions, it is possible to miss out certain states. For instance, ice under controlled conditions will go straight from ice to a gas, completely missing out the liquid water stage. Solid to gas equals sublimation. Gas to solid equals deposition. The comparison between Celsius and Kelvin. http://astronomy.swin.edu.or/cosmos/k/Kelvin. The content of this document is copyright symbol PIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, PIC Limited. Editor, PIC Limited. Design, PIC Limited. PIC Level 2 Diploma in Plumbing Foundation 35. Solids. The table shows some of the properties of solids. Property because solids have a fixed shape and cannot flow. The particles cannot move from place to place. Solids cannot be compressed or squashed. The particles are close together and have no space to move into. Liquids. The table shows some of the properties of liquids. Property because liquids flow and take the shape of their container. The particles can move around each other. Liquids cannot be compressed or squashed. The particles are close together and have no space to move into. Gases. The table shows some of the properties of gases. Property because gases flow and take the shape of their container. The particles can move quickly in any direction. Gases can be compressed or squashed. The particles are far apart and can Move into any space. AC 3.3 Identify the terms latent and sensible heat as they apply to liquids and gases. What is the difference between latent heat and sensible heat? The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 36. Sensible heat. Latent heat. When heat is directly applied to water, its temperature will rise until it reaches its boiling point. The resulting increase in the heat of the water is known as sensible heat because the application of heat has led to hotter water. Water at 0 OC to water at 100 OC equals a change in temperature due to the application of heat. There is no change of state. The process is reversible. Changes of state are also a result of heat added. But here, the added heat leads to a change in state, without an increase in temperature. Latent heat does not affect the water's temperature. For example, water at 100 OC to steam at 100 OC equals a change in state due to the application of heat. There is no change in temperature. The process is reversible. Heat energy is needed to increase the temperature of an object. The amount of energy needed depends on the mass of the object, the type of material it is made from, and the temperature increase. Heat energy is also absorbed when substances melt or boil, but the temperature does not alter during a change of state. The amount of energy needed to melt or boil something depends upon the mass of the object and the type of material it is made from. Take a look at the table below. It shows how much heat in kilojoules per kilogram that are needed to change 0 degrees Celsius of water to 100 degrees Celsius of steam. This table shows how much energy is required to raise 1 kilogram of water from 0 OC to 100 OC and change its state into steam. Pressure temp. Water. Sensible heat. Evaporation to steam. Latent heat. Total heat required. Bar K par degree C kJ / kilogram kJ / kilogram kJ / kilogram 00100.00257.02676.0 AC 3.4 Identify the methods of heat transfer. Within this assessment criteria, we will cover. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 37. Conduction. Convection. Radiation. Heat can be transferred from one place to another by three methods: conduction in solids, convection of fluids, liquids or gases, and radiation through anything that will allow radiation to pass. The method used to transfer heat is usually the one that is the most efficient. Conduction. Conduction occurs when heat travels through a substance, the heat passing directly from one molecule to another. If a piece of copper tube is heated at one end, the heat will quickly be felt at the other end. This occurs because kinetic energy in the form of heat is directly transferred from one copper atom to another very quickly. When the copper is cold, the molecules move slowly, but, as heat is applied, the atoms gain energy and collide with other atoms. The heat, or energy, is quickly passed from atom to atom, the cooler atoms gaining energy to collide with other slow, cooler atoms. Not all materials conduct heat at the same rate, and some, such as wood and plastics, do not conduct heat at all. The same principle can be applied to the conduction of electricity, as good conductors of heat are generally also good conductors of electricity. The rate at which a material will conduct heat is known as the coefficient of thermal conductivity. It is measured in W/m2K equals. The table below shows the coefficient of thermal conductivity of some common materials. Thermal conductivity of materials. Material. Thermal conductivity. W/m/K. Silver 406.0. Copper 397.0. Gold 317.0. Aluminum 225.0. Brass 109.0. Steel 50.2. Lead 34.7. Polyethylene HD 0.5. Wood 0.113. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 38. Convection. Convection occurs when heat is transferred through a fluid, i.e. a gas or a liquid. Convection takes place because the warm fluid is less dense than the cool fluid. As the lighter, warm fluid rises, it releases heat into the surrounding environment. As this happens, the warm fluid loses its heat, becomes denser and falls by the effect of gravity, to begin the process again. In a hot water system, this is known as gravity circulation, as hot water rises and cooler water moves down to replace it, causing a circular motion. Modern convector /radiators use two methods of heat transfer to warm rooms and spaces: convection and radiation. Radiation. All objects will transmit and receive heat in the form of thermal radiation, often called infrared radiation. The hotter an object is, the more thermal radiation it will emit. Thermal radiation is a type of electromagnetic radiation and, unlike conduction and convection, the heat does not pass from atom to atom. Instead, it travels in waves. On Earth, we get the heat to warm our planet from the sun. The sun's heat travels over 90 million miles through the cold vacuum of space to warm the Earth's surface. The heat is felt because it travels in waves, without heating the space between them. We use the same principle with central heating radiators. The heat from the hot water in the heating system heats the steel radiator through conduction, and the radiator heats the room by radiation. AC 3.5 state how units of energy and heat are related and derived. Within this assessment criteria, we will cover energy joules, J. Specific heat capacity, kJ/kilogram/degree C. Power watts, W. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 39. Maximum density. Coefficient of linear expansion. SI units of energy, heat and power. Energy joules, J, the SI unit of work or energy, equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of the force. It is equivalent to 13,600 th of a watt-hour. Specific heat capacity, kJ/kg/degree C. This is the amount of energy required, in joules or kilojoules, to increase the temperature of 1 kg of a substance by 1 degree Celsius. Water, for example, has a SHC of 4.19 kJ/kg/degree C. This means that it takes 4,190 joules of energy to raise the temperature of 1 kg of water by 1 degree Celsius. Power watts, W. The watt, abbreviated W, is the International System of Units standard unit of power, or energy per unit time. It is the equivalent of 1 joule per second. The watt is used to specify the rate at which energy is dispersed, or the rate at which electromagnetic energy is radiated, absorbed, or dissipated. The watt can be used to describe electrical power or heat power. AC 3.6 state how to carry out heat, energy and power calculations. Within this assessment criteria, the range will cover quantity of heat energy required to raise the temperature of a substance, the amount of power required to heat a substance. To recap, the SI units of measurement of energy, heat and power are energy the joule, J, heat the joule, J, power the watt, W. Specific heat capacity kilojoules per kilogram per degree Celsius, kJ/kg/degree C. Remember, the specific heat capacity of water is 4.19 kJ/kg/OC. Calculations using the specific heat capacity of water. Example 1. How many kilojoules would it take to heat 200 liters of water from 40 degrees Celsius to 80 degrees Celsius? The formula for this is E, where L equals liters, ET equals temperature difference, SHC of water equals 4.19. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 40. Therefore, 200, 80 40, 4.19 equals. Example 2. This equation can be further developed to calculate how many kilowatts it would take to raise the temperature of the 200 liters water by 40 degrees Celsius. To do this, we need to include an amount of time, i.e. 1 hour, 2 hours, 3 hours etc. Assume that you require 200 liters of water at 80 degrees Celsius in 2 hours time. E, where L equals liters, ET equals temperature difference, SHC of water equals 4.19. 2 hours in sex equals 2x, 60x60, equals 7,200. Therefore, 200, 80 40, 4.19. 7,200 equals 4.65. This shows that to increase the temperature of 200 liters of water from 40 degrees Celsius to 80 degrees Celsius in 2 hours would take 4.65 kilowatts of heat Example 3. This can be even taken a step further. How many hours would it take for 200 liters of water to be heated by 40 degrees Celsius using a 6 kilowatts of power? Remember, water has a specific heat capacity of 4.19 kJ/kg/degree C and that 1 W equals 1 J/S. The formula for this is where L equals liters, T equals temperature, kilowatt equals kilowatts, SHC equals specific heat capacity. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 41. Therefore, 244.196 equals 5586.666667. To convert seconds into hours. 6060 equals. Therefore, 5586.666667. 3600 equals 1.55133. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 42. Advert. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 43. Learning Outcome 4. Know the principles of force and pressure and their application in the mechanical services industry. There are 5 assessment criteria in this learning outcome. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 44. AC 4.1. State how units of force and pressure are derived from SI units. AC 4.2. State the application and use of units of measurement of pressure and flow rate. AC 4.3. State how to carry out simple force and pressure calculations. AC 4.4. Identify the relationship between velocity, pressure and flow rate in systems. AC 4.5. Identify the reasons why pipework restricts the flow of liquids and gases. Force, pressure, flow rate and velocity play a major part in plumbing systems. To fully understand how plumbing and heating systems work, we must first master the difference between flow rate and pressure. These subjects, although very different, are interlinked. Where there is one, you will always find the other. In this part of the science unit, we will investigate those elements that are fundamental in plumbing theory. Force, pressure, velocity and flow rate. We will also look at how these elements can be adversely affected, and learn how to conduct simple pressure and flow rate calculations. AC 4.1 State how units of force and pressure are derived from SI units. Within this assessment criteria, we will cover acceleration, m/s2, force due to gravity, force, Newton, N, Pressure, N/m2. Atmospheric pressure. Flow rate, m3/s. The table below shows the derived units of force and pressure. Units of force and pressure. Velocity, the rate and direction of the change in the position of an object, m/s meters per second. Acceleration is defined as the rate at which an object changes its velocity, m/s 2 meters per second squared. Flow rate, the amount of fluid that flows in a given time, m3/s meters cubed per second. Force. A force is a push or pull upon an object that causes a change in the motion of that object. N. Newton, equal to kilogram/m/s2. Force due to gravity. The force of gravity is the force exerted by the gravitational field of a massive object on any body within the vicinity of its surface. Fg. Pressure. Pressure is an expression of force exerted on a surface per unit area. Pascal, equal to N/m2. Atmospheric pressure. An atmosphere, atom, is a unit of pressure based on the average atmospheric pressure at sea level. The actual atmospheric pressure depends on many conditions, for example altitude and temperature. Atom. bar/Pascal/ millibars. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 45. AC 4.2 state the application and use of units of measurement of pressure and flow rate. Within this assessment criteria, the range will cover pressure O bar/millibar, O kPa, O psi, O meters head. Flow rate O m3/s, O L/s, O kilogram/s. Pressure. The standard unit of pressure is the pascal. However, other units, such as pounds per square inch, psi, bar, and meters head, may also be used when describing pressure. The relationship between these four units is shown in the table below. Flow rate. In plumbing and heating, the volumetric flow rate is the volume of fluid which passes per unit time. The psi unit is m³/s, in other words, the volume of water, in m3, that flows every second, s. However, since we know that 1 m3 of water has a mass of 1000 kilograms and that 1 kilogram of water is equal to 1 liter, then the flow rate can also. Unit of pressure conversion chart. Kilopascals, kPa, bars meters head of water. Pounds per square inch. P.S.I. 10.0.111.42. 20.0.222.84. 30.334.27. 40.445.68. 50.557.11. 101.1014.22. 151.51521.33. 202.2028.44. 252.52535.55. 303.3042.66. 353.535.49.77. 404.4056.88. 454.5 45 63.99 500 550 71.10. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 46. Be represented in various other ways to M3/S L/S kilogram/S. For example, if a tap discharges 0.3 M3/S, then 0.3 Y equals 300 equals 300. In this case, the flow rate could be quoted as 0.3 M3/S or 300 L/S or 300 kg/S. The application of pressure and flow rate measurements. Pressure and flow rate are the key points that any plumbing system will be measured by. If the flow rate or the pressure is poor, then this can be the result of poor design, poor installation or both. Good plumbing design and installation will deliver the desired pressure and flow rate for a given specification. However, we must also be aware that too much pressure or too high a flow rate can be detrimental, as they can cause noise and erosion problems in pipework and fittings, and this may lead to breakdown or failure of the pipework or components. In heating systems, too much flow rate can be detrimental, as this causes unwanted noise. We will examine pressure and flow rate later in this section. AC 4.3 state how to carry out simple force and pressure calculations. Force. In physics, force is the influence on a static object that causes the motion of the object to change. If the object is subjected to force, it will begin to move. Consider the following example. A pipe is connected to a cistern at one end and a tap at the other. The cistern is situated in the roof space, and the tap is in the bathroom. While the tap is closed, the water can be said to be at rest because it is not moving. When the tap is opened, the water moves from the cistern, down the pipe and out of the tap. The water is being acted upon by the force of gravity, causing it to move. We can calculate the amount of force acting downwards on the cistern that causes the water to flow. The cistern contains 100 liters of water. Since 1 liter equals 1 kilogram, then the mass of the cistern is 100 kilograms. Therefore, 9.81 equals 109.81 equals 981. So, the force acting on the water is 981 N. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 47. Force, however, does not give the pressure of the water at the tap. Force only gives an indication of the gravitational pull downwards on the water. Water pressure is calculated slightly differently, and this will be discussed in Part C, a little later in the unit. Pressure. Physics defines pressure as force per unit area. The weight of, say, a cistern sitting on a platform in a roof space is measured in N/m2 or newtons per square meter. If the cistern was of equal dimensions, length, width and height, then the weight being exerted onto the platform would be the same irrespective of whether the cistern was on its bottom, side or end. If the cistern has unequal dimensions for the length, width and height, then different pressures will be exerted depending on which of the sides is face down. Take a look at the following calculation. A cistern measuring 0.9 m long x 0.8 m wide x 0.7 m high is to be installed on a platform in a roof space. What pressure would it exert on the platform if the cistern was placed on its bottom, length x width? The cistern was placed on its side, length x height. The cistern was placed on its end, width x height. Before we can attempt these calculations, we must first determine the mass of the cistern in kilogram. The formula for this is mass equals y. 0.9 0.8 0.7 equals 0.504 y. Then, we must convert the volume into mass of water. To do this we must multiply the volume by 1000 to convert the mass into liters. 1000 equals 0.504 1000 equals 504. Since 1 liter of water has a mass of 1 kilogram, then equals. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 48. 504 equals 504. From an earlier calculation we know that 9.81 equals. So 504 9.81 equals 4944.24. Therefore, the cistern has a force of 4494.24 N. The formula for finding the pressure exerted is pressure equals divided by equals area of the bottom of the cistern. 0.9 0.8 equals 0.72. 4944.24 divided by 0.72 equals 6867. Area of the side of the cistern. 0.9 0.7 equals 0.63. 4944.24 divided by 0.63 equals 7848. Area of the end of the cistern. 0.8 0.7 equals 0.56. 4944.24 divided by 0.56 equals 8829. From these calculations we can see that the greater the surface area for a known mass of water, then the less force is exerted by the mass onto the platform. This is very important when we are deciding on where to place large cisterns that will contain a lot of water. The greater area we can present to the platform, the better the spread of the weight across the platform, creating less stress on the structure. Water pressure. The pressure that is exerted by water is due to its mass and is determined by the height of the source from the outlet. Water pressure can be measured when the water is flowing and when it is not flowing. These two methods are known as. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 49. 1. Static pressure, head, water that is not flowing. 2. Dynamic pressure, water that is flowing. Static pressure, head, water that is not flowing. The image shows a cistern full of water with a pipe connected to a tap. It is the distance between the cistern and the tap, measured from the bottom of the cistern to the outlet of the tap, that creates the water pressure. It is measured in pascals, pa. This is known as the static head or head of water. Every meter of height, or head, between the two increases the water pressure by 10 kilopascals. As we have seen previously, water pressure is also measured in bar and psi. 1 equals 1, 0 equals 0.1. So, 1 0 equals 100 equals 1. Dynamic pressure water that is flowing. Dynamic pressure is also known as working pressure. It is the pressure of the water when it is flowing. This will generally be less than the static pressure because it is affected by other factors. If the static pressure of the water is increased, then the effect would be that the flow rate of the water and its velocity would also increase. However, this can cause additional problems with unwanted noise and pipe erosion. Remember, flow rate plus pressure equals noise. AC 4.4 Identify the relationship between velocity, pressure and flow rate in systems. Within this assessment criteria, we will cover effects of increasing forward/reducing pressure, effects of increasing forward/reducing pipe size. Velocity, pressure and flow rate are linked. Increasing the static water pressure will increase the velocity of the water, and therefore the flow rate, because the water is flowing with more force through the pipe. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 50. Decreasing the static pressure will also decrease the water velocity and therefore reduce the flow rate. Decreasing the pipe size will reduce the flow rate and increase the velocity because of the Bernoulli effect. The Bernoulli effect describes the relationship between flow velocity and pressure of a fluid, i.e. water. It states that when the water passes through a reduction in pipe size, then the velocity of horizontal flow will increase and the pressure will decrease. This effect was discovered by Daniel Bernoulli in 1738. If the water is moving uniformly through the pipe, then the only forces acting on the water are its own weight and the static pressure of the water itself. If the pipe reduces in size, the water must speed up, because the same amount of water is trying to flow through a smaller space. The only way the water will move faster is if the pressure behind the fluid is greater than the pressure in front. Thus, the pressure must decrease as velocity increases. Increasing the pipe size has a reverse Bernoulli effect, and this increases the pressure and reduces the velocity. AC 4.5 Identify the reasons why pipe work restricts the flow of liquids and gases. The material of the pipe. Different materials offer different resistance to the flow of water. Copper tubes and plastics are smooth internally and give little resistance to the flow of water. Low-carbon steel, by contrast, is very rough internally and offers a greater resistance. This in turn decreases the pressure. Changes of direction. Elbows, bends and the junction of T-fittings also offer resistance to flow, and this too will reduce the pressure. An elbow, for example, has the same resistance as around 0.5 m of pipe, 0.3 m of pipe if machine-made bends are used. So if the pipe run has 6 elbows, or 6 changes of direction, this is equivalent to an extra 3 m of pipe. The Bernoulli effect. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 51. Length of pipe run. Again, the greater the length of pipe, the more resistance is encountered. This will effectively reduce the pressure and the flow rate of both water and gases. Pipe size. The bigger the pipe, the greater the volume of water or gases. Restrictions such as valves and stop taps. These reduce both pressure and flow rate because they offer resistance to smooth water flow. Reductions in pipe size. A pipe size reduction reduces the pressure and the flow rate but increases the velocity. It is known as the Bernoulli effect. Roughness of material surface. The rougher the pipe material, the greater the resistance to flow. Principles of a siphon. The principle of a siphon is to move water from a high place to a low place using only atmospheric pressure. And the cohesive properties of water. In the diagram, the two containers are both at atmospheric pressure. But container A is higher than container B. This means that the pressure at container A will be slightly lower than container B. For the siphon to work, the hose inlet at container A must be higher than the hose outlet at B. When suction is applied to the hose outlet, B, the water will flow upwards, over the top of container A where the pressure is lower. At this point, gravity and water's cohesive qualities take over and the contents of container A simply flow by gravity into container B. A. B. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 52. Learning Outcome 5. Know simple mechanical principles and their application in the mechanical services industry. There are two assessment criteria in this learning outcome. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 53. AC 5.1. State the principles behind simple machines. AC 5.2. Identify the principles of basic mechanic. AC 5.1 State the principles behind simple machines. A simple machine is one which aids the lifting and moving of loads that are too heavy to lift or move on their own. They give a mechanical advantage known as the velocity ratio to human effort. Simple machines fall into four main categories. 1. Levers. 2. Pulleys. 3. Archimedean screws. Simply put, they multiply the effort or force that is exerted by the operator. Levers. A lever consists of a rigid bar which turns about a fixed point called a fulcrum. The weight to be lifted is known as the load and the force applied to lift it is known as effort. The distance from the fulcrum to the load is called the load arm and the distance of effort from the fulcrum is known as the effort arm. There are three classes of lever. First-class lever. A first-class lever is one where the fulcrum lies between the effort and the load in a seesaw style. Examples of this include scissors, pliers, crowbar. Second-class lever. A second-class lever is one where the load is between the fulcrum and the effort. Examples of this are a wheelbarrow, a bottle opener. Third-class lever. A third-class lever is one where the effort is between the fulcrum and the load. Examples of this are a shovel, a fishing rod and the human forearm. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 54. Pulleys. A pulley can be described as one or more grooved wheels that rotate on an axis over which a chain or rope is looped. They are designed for lifting heavy objects by multiplying the lifting force. They are also known as block and tackle. There are three basic types. The single pulley system. The single pulley reverses the action of the force. In other words, by pulling down on the pulley rope, the load will go up. An equal force must be applied to the load to lift the load. So, if the load has a weight of, say, 100 N, then an equal force or effort of 100 N mass must be exerted to lift it. A lift of 1 M will require a downward movement of 1 M also. If more pulleys are added, then the lifting effort required will be reduced. The double pulley system. With the double pulley system, the weight of the load is supported by two ropes. Now, the force or effort needed to lift the load is halved. The mechanical advantage is twice the advantage of the single pulley system. The disadvantage is that to lift the load 1 M, a downward movement of 2 M is needed. The 4-pulley system. If 4 pulleys are used, the load is now supported by 4 ropes. This means that each rope is taking 25% of the load, in this case, 25 N. This means that only 25% of the weight of the load is needed to move the load upwards. The disadvantage is that a 4 M movement of effort downwards is needed to raise the load 1 M. Archimedean screws. An Archimedean screw is a simple machine that converts rotational movement into straight-line movement. They can be placed in any position, vertical, horizontal or at an angle. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 55. Invented by Archimedes, 287-212 BC. The principle of the Archimedean screw is a simple one. A cylinder with an inclined plane wrapped around it is rotated. As can be seen by the image above, the water is moved up or down the inclined plane as it rotates. In this way water can be moved from a low reservoir to a higher one, or vice versa. The following formula is used to calculate the mechanical advantage of a screw. Equals. Where Ma equals mechanical advantage. Pi equals 3.142. D equals diameter. L equals length. Wheels and axles. The wheel and axle is a simple lifting machine comprised of a large grooved disc and a small disc or cylinder joined at the center or the fulcrum. The large disc is known as the wheel and the small disc is known as the axle. The principle of use is very straightforward. By turning the large wheel, any weight attached to the axle will be lifted, such as a bucket full of water being lifted from a well. The wheel multiplies the torque of the turning action, hence the bucket is lifted. The principle of a wheel and axle can be expressed mathematically. Equals. Tools such as spanners and grips use this principle. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 56. AC2. Outline Principles of Basic Mechanics. Within this assessment criteria, the range will cover theory of moments, action and reaction, center of gravity, equilibrium, velocity and ratio, mechanical advantage. The theory of moments. The moment of force is the measure of the turning effect, known as the torque, which is produced by force acting on a body, and is equal to the applied force and the perpendicular distance from its line of action to the pivot about which the body turns. The unit of measurement is the Newton. The moment of force is calculated using the following equation. Equals. Or. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 57. Equals. The easiest example of a moment of force is a spanner turning a nut. The spanner amplifies the force. The longer the spanner handle, the larger the moment. The spanner is a force multiplier. The turning force, or torque, is multiplied by the spanner, making the nut much easier to tighten. Action and reaction and Newton's third law of motion. Newton's third law of motion states that for every action, there is an equal but opposite reaction. But what does this mean? A push or a pull on a stationary object will create a reaction, but only if the push or pull force is greater than the force of the stationary object. If both the action and the reaction are equal, then the object will remain stationary. Consider a balloon full of air. If the balloon is released, then the air will rush out of the balloon and the balloon will fly off. The same principle occurs with jet engines on an aircraft. If the thrust, force, from the engine is greater than the stationary force, weight, of the aircraft will move. When we sit on a chair, the downward force of the person sitting on the chair, the action, provokes a reaction from the chair. To be able to withstand our weight, the chair must push against us with equal force, or equilibrium. If it didn't, it would simply collapse. So, it can be said of Newton's third law that every force that an object is subjected to, there is an opposing force from the object. Both action and reaction forces are equal. Forces always come in pairs, action / reaction. Equilibrium. When all forces acting on an object are equal, left, right, backwards, forwards, up, down, the object will be stationary. The object is in a state of equilibrium. Look at the diagram left. All forces are 50 N and so the object is in equilibrium and stationary. The same applies to unequal forces too. Providing the opposing forces are equal, then a state of equilibrium will still exist. If the thrust pushes backwards, spacecraft moves forward. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 58. Up/down forces are, say, 50 N but the left/right forces are 30 N, then the object will still be in equilibrium and the object will remain stationary. Up/down forces are 50 N, left/right forces are 30 N and so the object is in equilibrium and stationary. The key word is balanced. Look below. Movement occurs in the right-hand drawing because the left/right forces are unbalanced. There is a force of 20 N acting on the object pushing the object to the left. Center of gravity. The center of gravity of an object is that point where all of the weight of the object is concentrated. This is especially important in tall buildings and bridges, and where a designer must predict the gravitational effect on a moving object, such as train or a car. It is also known as the center of mass. The actual center of gravity varies from object to object and in symmetrically shaped objects, coincides with the object's geometric center. In asymmetrical shapes, irregular, the center of gravity may be distance away from the object's physical center. In hollow objects, such as an empty box, the center of gravity will be in free space, away from the object's actual structure. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 59. Advert. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 60. Learning Outcome 6. Know the principles of electricity as they relate to the mechanical services industry. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 61. There are 4 assessment criteria within Learning Outcome 6. AC 6.1. State the basic principles of electron flow theory. AC 6.2. State the purpose and application of simple units of electrical measurement for use in the mechanical services industry. AC 6.3. State how to carry out simple electrical calculations. AC 6.4. Identify the requirements for earthing of electrical circuits. Electricity is crucial to modern living. It powers the appliances we use every day, both at home and at work, and enables us to communicate with people all over the world instantly. It is something we all take for granted, but what is electricity? In this, the last learning outcome of the unit, we will find out about electricity, how it is generated, its laws of physics and basic circuitry. AC 6.1 State the basic principles of electron flow theory. Basic principles. Everything on Earth is made up of atoms. Atoms are not solid. At the center of every atom is a nucleus, which consists of an equal number of positively, plus, charged protons and negatively, charged neutrons, making the atom electrically neutral. The neutrons play no role in the electrical properties of atoms. Their sole purpose is to hold the nucleus together. Without them, the nucleus would fly apart. Revolving around the nucleus is the electron. These two have a negative charge. As can be seen from the image, the atom is very similar to a mini solar system, with electrons orbiting the nucleus like the planets around the Sun, and, just like a solar system, those electrons nearer the nucleus orbit more quickly than those further away. The electrons that are furthest away are less attracted to the atom, and are easily deflected from their weak orbits, to be attracted by other atoms. It is this constant movement of electrons from one atom to another that makes electricity possible. Materials that allow the free movement of electrons are called conductors. Those that prevent movement are called insulators. Measurements of electrical flow. Electricity is measured in two ways. One by the number of electrons flowing. This is called the current and it is measured in amperes or amps. Two by the amount of pressure, or the push, which causes the current to flow. This is measured in volts. Voltage is created by the electrons which, being negatively charged, repel each other. When electrons are. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 62. Concentrated in one place, they will flow freely away provided the path is clear for them to do so. It is the voltage, or push, that makes them move. If there are lots of electrons in one place, the voltage is high and many electrons will flow through the conductor. The more electrons that flow, the better the conductor. The direction of movement of the negatively charged electrons is random unless a force acts upon them to move them in the same direction. This is electromotive force, EMF, better known as electricity. How well a material allows electron movement is called conductivity. How well a material resists electron flow is called resistivity. Material conductivity and resistance. Conductivity is the ability of the material to allow the movement of electricity. A good conductor allows free movement of electrons, whereas a poor conductor resists the flow of electrons. Silver is the best conductor of electricity with copper a close second. However, copper is much cheaper to manufacture into electrical cables and has less mass. Silver equals 10490 kg/m3, copper equals 8960 kg/m3. Resistivity is the opposition to electron flow. It is the resistance of the material against the flow of electricity. When a metal resists the flow of electricity, the energy can be transformed into other forms of energy, such as heat and light. For example, when electricity passes through the resistance of a heating element in an electric kettle, the water will eventually boil. Similarly, when electricity passes through the filament of a light lamp, light is generated. The amount of resistance will depend on the material. Direct and alternating current. There are two different types of electricity. 1 direct current, DC. 2 alternating current, AC. Direct current, DC. Direct current is generated by a number of sources. It can be generated by photovoltaic, PV, panels or as a result of an electrochemical reaction. DC current can be stored in cells and batteries. In a DC circuit, the electrons will always flow from the negative pole to the positive, plus, pole. The direction of the electrons, known as the polarity, never changes. The negative electrons will always seek the positive. It never reverses. The symbol for DC current. The content of this document is copyright symbol BPIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BPIC Limited. Editor, BPIC Limited. Design, BPIC Limited. BPIC Level 2 Diploma in Plumbing Foundation 63. Alternating current, AC. Alternating current does not travel in one direction. It reverses its direction of travel from positive to negative and from negative to positive, constantly. In other words, it alternates. In the UK, AC current alternates 50 times every second. This is known as the frequency and is measured in Hertz. In the UK, the electricity supply is 230 V50 Htz. Below is a table of the advantages and disadvantages of AC current. AC 6.2 state the purpose and application of simple units of electrical measurement for use in the mechanical services industry. The terminology of electricity covers subjects such as current, voltage, resistance and power, but what are these measurements and what do they mean? The advantages and disadvantages of AC current. Advantages, disadvantages. Voltages can be transformed easily from one voltage to another. DC voltage is hard to transform. AC current can be transported over long distances without excessive voltage loss, making it much more efficient than DC voltage. AC current cannot be stored. It is generated at power stations and bulky portable generators. AC power tools need long cables, which can be a trip hazard. DC power tools use battery power and are much more portable than AC power tools. The symbol for AC current. Alternating current sine wave. The content of this document is copyright symbol BPIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BPIC Limited. Editor, BPIC Limited. Design, BPIC Limited. BPIC Level 2 Diploma in Plumbing Foundation 64. Voltage, volts. In a circuit where there are more electrons in one part of the circuit than the other, the electrons will flow from the area of concentration to the area where they are absent. This difference in electron concentration is known as the potential difference or voltage. The higher the voltage, then it can be assumed that there is a greater imbalance and the harder the electrons will repel each other. This leads to greater current or flow in amps in the circuit. The voltage in a circuit can be calculated. Omega. Resistance. Resistance is the opposition to electron movement through a conductor. Every electrical circuit has resistance. Some circuits have more resistance than others. In some circuits, resistance is necessary to reduce the amount electrons flowing, whilst in others as little resistance as possible will ensure high current flow. The interaction between current, or electron flow, voltage, current flow, and resistance is shown in ohms. Law. As the voltage increases, more electrons will flow. Increasing the voltage leads to an increase in current. However, if the resistance is increased, this reduces the current flow and the amps in the circuit. The resistance in a circuit can be calculated. Divided by, equals, omega. Current. The rate at which electricity flows through an appliance is known as the current. It is measured in amps. The easiest way to understand current is through a water analogy. A 15 mm pipe at 2 bar pressure will deliver a set flow rate. If we want to increase that flow rate, we would need a bigger pipe. If we increased the pipe size to 22 mm, then the pressure would be the same but the flow rate would be greater. In electrical terms, the voltage is the pressure and the current is the flow rate. If we increase the cable size, the voltage, pressure, remains at 230 V but the current, flow rate, is greater. The SI unit of measurement of electrical current is the ampere or amp, I. The current in a circuit can be calculated. Divided by, omega, equals power. When electricity is converted into other forms of energy, such as light, heat or mechanical, it is called power. It is equal to the sum of the current and the voltage. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 65. An immersion heater, rated at 3 kW simply means that the electrical energy is converted into heat to warm the water. Electrical power is the rate at which electrical energy is consumed and is defined as 1 joule per second. The SI unit of measurement of electrical power is the watt, W. The power in a circuit can be calculated. V equals AC 6.3 State how to carry out simple electrical calculations. Ohm's law. Ohm's law states the current through a conductor between 2 points is equal to the voltage across the 2 points, and inversely proportional to the resistance between them. It defines the relationship current, voltage, resistance and power. According to Ohm's law, 1 ohm is the resistance through which 1 volt will maintain a current of 1 amp. In theory, if we have two electrical values, then we can calculate a third. In the following calculations, the diagrams below show Ohm's triangle and the power triangle. By covering the unit you are calculating with your finger, the remaining units are needed in the calculation. For example, if we are calculating voltage, cover the V and we are left with. If we are calculating resistance, cover the R and we are left with. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 66. Simple calculations using Ohm's law. Example 1. What size of overcurrent protection device will be needed to protect a circuit that has a 3 kW immersion heater installed on a 230 V supply? The formula for this is equals divided by. Therefore, first, convert the kilowatts to watts by multiplying by 1000. Equals. Now complete the calculation. Divided by equals. Example 2. Using the formula power, P, equals voltage, V, x current, I, calculate the current flowing to a 10 kilowatt shower fed by a 230 volt AC supply. Look at the ohms triangle. Since we only know the power and the volts, we will need to transpose the equation to find the amps. I equals divided by 10 equals 10,000. Therefore, 10,000 divided by equals 43.47. Example 3. Using the Ohm's law formula, voltage equals current x resistance. Calculate the voltage in a circuit which has a resistance of 115 ohms and a current of 2 amps. The formula for this is equals. Therefore, equals. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 67. Example 4. Using the Ohm's law formula, resistance equals volts divided by current. Calculate the resistance in a circuit when the voltage is 110 V and the current is 45 amps. The formula for this is equals divided by. Therefore, divided by equals voltage, current and resistance in series and parallel circuits. There are two types of circuit: A. Series. B. Parallel. Series circuits. A series circuit has only one path from the power source through the circuit loads and back to the power source. In this instance, the current must flow through all of the loads. This circuit depends upon all of the lamps working perfectly. If one of the lamps fails, then the whole circuit will fail and none of the lamps will light up. This is because the current flows from one lamp to the next. It is the only path from the power source and back again. Consider the circuit to the right. The circuit has one lamp connected to a 230 V electricity supply. The lamp will glow at full brightness simply because it is receiving all of the current. To find the resistance in the circuit, we must first find the current, I. Since we know the power, 40 watt, then equals. Therefore, the current, amps, is equals. Now, we can apply Ohm's law to find the resistance. 60W. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 68. Equals. Therefore, equals. If a second lamp with the same 40 watts is added to the circuit, then the resistance in the circuit will double and the current flow is half that when there was only one lamp. The voltage is now only 115 V2. Each lamp, and this halves the brightness emitting from each lamp. Both lamps have the same voltage drop. Again, firstly, we must find the current. Equals. Therefore, the current, amps, is equals. 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 Now, we can apply Ohm's law to find the resistance of each light lamp. Equals. Therefore, equals. 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 60W60W. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 69. Now find the total resistance of the circuit. Equals plus. Equals. Plus. Equals. To find the current across the circuit using the total resistance. Equals. Therefore. Equals. To find the voltage, since each lamp is 40 watts with a resistance of 1763.3307 ohms and the total circuit current is 0.13043 amps, to find the voltage to each lamp. Equals. Equals. Because each lamp is only drawing 115 V, each lamp will only glow with half its potential brightness. To find out how many watts is being generated. Equals. Therefore. Equals. Now, let us add a third lamp, but this time with less power. Here, there are 3 lamps, 2x 60 watt and 1x 10 watt. We must find the current to each light lamp. Equals. 60W 60W 10W. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 70. Equals. 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 Now, we can apply Ohm's law to find the resistance of each light lamp. Equals. Therefore. Equals. 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 Now find the total resistance of the circuit. Equals plus plus. Equals. Plus. Plus. Equals. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 71. To find the current across the circuit using the total resistance. Equals. Therefore. Equals. To find the voltage to each lamp. Equals. At equals. Equals. At equals. Equals. At equals. Equals. Because each lamp is drawing less voltage, each lamp will only glow with a fraction of its potential brightness. Parallel circuits. A parallel circuit has at least 2 independent paths in the circuit. In a parallel circuit, each light lamp has its own independent path to the power source. This means that the lamps are unaffected by each other. If one lamp fails, the other 2 will continue to work. Voltage is equal across all components. However, the current increases when more light lamps are added, and if too many are installed, then the circuit will overload. To find the current at each lamp. Equals. Therefore. Equals. Equals. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 72. Equals. 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 Plus. Plus. Equals. To find the resistance of each lamp. Equals. 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 equals equals. To find total resistance of the circuit, equals plus plus equals plus plus. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 73. Equals plus plus equals equals equals. The chart below shows that the voltage stays the same and that the total resistance in the circuit decreases, whilst the watts and amps increase. AC 6.4 Identify the requirements for earthing of electrical circuits. Electricity will always take the least line of resistance to earth, even if that line is us. If we accidentally touch an electricity source, the current will always flow through our bodies to get to the earth, causing a dangerous, sometimes fatal, electric shock. The reason for this is simple: electricity always wants to complete the circuit. The need, then, for a good earthing system is of utmost importance. Here we will look at the need for good earthing and equipotential bonding of electrical circuits. Earthing. To prevent damage and electric shock caused by electrical faults, all electrical installations must be earthed. This is provided by a dedicated earth wire that permanently connects every socket and light fitting to a dedicated metal earth connecting block at the consumer unit. R1, R2, R3 total. Volts 230, 230, 230, 230. Amps 0.173910, 0.26086, 0.43478, 0.86955. Ohms 1322.523, 881.699, 529.003, 264.55. Watts 40, 60, 100, 200. Ohm's law applies. V equals 230, V equals 264.50 ohms. I 0.86955. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited. BIC Level 2 Diploma in Plumbing Foundation 74. When an electrical fault occurs, the current is carried safely away from the fault to earth via the earth cable. This change in electrical flow will blow a fuse or cause the residual current device, RCD, to trip out, disconnecting the electrical supply to the circuit where the fault is located. The earth cable is colored green and yellow, with most households needing 16 mm bonding into the fuse board and 10 mm to the water and gas. When supplementary bonding metallic sinks, basins, baths and shower trays, 4 mm single core earth wire should be used. Plastic pipework does not require bonding. Some electrical appliances also have a green / yellow earth flex. The earth wire must always be connected to the earth pin on the plug. The ring main and lighting installations are usually completed in twin / earth cable. In this cable type, the earth cable is an unsheathed copper wire. A green / yellow sheathing has to be placed over it at installation stage. Equipotential bonding. Every metal pipe and fixture in a property, such as central heating pipe work, gas pipe work, cold water pipe work, Stainless steel sinks and wash basins and cast iron baths must be potentially bonded using a bonding clamp connected by a green /yellow cable. This is to ensure that all metal fittings have the same zero electrical potential. When attaching a bonding clamp, it is essential that a good connection to the metal be made. This is done by cleaning the pipework of any paint or corrosion before attaching the clamp. If plastic connections have been made to copper pipework, this must be permanently bridged to ensure a good cross-bonding of pipework. Earth bonding when plastic fittings have been used. Earth bonding clip. The content of this document is copyright symbol BIC Limited 2020 and may not be copied, reproduced or distributed without prior written consent. Author, BIC Limited. Editor, BIC Limited. Design, BIC Limited.